Hi, in this video, we will be doing the sprinkler system design, pipe routing, pipe sizing, then quick response sprinkler area reduction calculation, then hydraulic calculation, everything we can discuss. Okay, let's start. Actually, we are having a car parking area. What occupancy hazard category will come for this car parking area? We have to find. Okay, for this car parking area, I'm just going to do the sprinkler layout. We can go to NFPA 13. NFPA 13, let me search it, that is automobile car parking. Car parking area, you can see automobile parking area normally will come under ordinary hazard, group 1 category. Okay, ordinary hazard group 1 category only. So that's why car parking area will come ordinary hazard group 1. And the ceiling height means from the finished floor level to the bottom of false ceiling or from the bottom of slab. If you're not having a false ceiling, from the bottom of false ceiling you have to consider, means from the finished floor level, this is your floor, and if this is your finished floor level, if you're having false ceiling, from the finished floor level to false ceiling level you have to consider. If you're not having false ceiling, from the bottom of slab you have to consider it. Anyhow, car parking area we are not having any false ceiling, so that's why from the finished floor level to bottom of slab we are having like 4 meter height here. 4 meter means 4 into 3.28, that will be getting like a 13.12 feet. Okay, these are details. It's a plain area. So I have to place the sprinklers. How many number of sprinkler I required inside? Number of sprinkler that we can calculate with respect to the coverage area of a single sprinkler. Okay, for example, in NFPA 13, National NFPA 13, page number 55, I am going. Here you can see the protection area. Protection area, this table will be for light hazard category, but we are dealing with ordinary hazard. So you can see protection area of maximum spacing of standard, pendant and upright. We'll be proposing the quick response pendant type only. We can discuss. Okay. So the protection area for a single sprinkler will be 130 square feet or 12.1 meter square. And the maximum distance between the sprinkler will be 4.6 meter. Anyhow, minimum distance will be the sprinkler will be 1.8 meter only. So let me take the drawing, and maximum distance, if you can go to page number 55, let's say as per NFPA. In ordinary hazard category, this table, for ordinary hazard category, the protection area of a single sprinkler will be 130 square feet. And the maximum spacing between the sprinkler will be 4.6 meter. Minimum spacing between the sprinkler is 1.8 meter only. Okay, let me take the dimension of this space. So the dimension of this one will be, this is 16 meter. This is in millimeter only. So millimeter divided by 1000, you will be getting that in meter. 16 meter by 20 meter. So how we can place? The approximate number of sprinkler you can calculate, but because the protection area of a single sprinkler will be 130 square feet. So how much square feet we are having there? Correct. Protection area of a single sprinkler is 130 square feet. So the approximate number of sprinkler will be, the floor area is 20 into 16. 20 into 16, this much meter square will come. So meter square multiplied by 10.765, you can find the square feet. So the entire area will come 3,444 square feet. So divided by 130, one sprinkler will be covering 130. So approximately we need 26 number, but we can't simply provide the 26 number there. The easy method, I will explain how to place it. Anyhow, 16 meter, no, I'll be making a line in between. In between the boundary, I'll be making a line. Okay. And you know, this line is 16 meter. And as per NFPA, the maximum spacing between the sprinkler will be 4.6 meter. So the number of sprinkler that I can place here, number of sprinkler I can place in this direction will be 16 meter divided by 4.6 meter. How much it is? 3.47 numbers. 3.47 number of sprinkler has to be placed. 3.47 is not possible. You have to round that into 4 number. Okay, 4 number. So next step, so in this side, X side, I'm just going to place 4 number of sprinkler. So if you are planning to place 4 number of sprinkler, this line you have to divide it by 8. Number of sprinkler into 2 times. For example, if the number of sprinkler that you are planning to locate like place 4 number, so this line has to be divided by 8. The number of sprinkler that you are planning to place 3 number, then this line has to be divided by 3 into 2, 6 number. Anyhow, my selected that is DIV. My case, it is 8 number. Select the line for dividing. And 4 number has to be placed. So the division will be 8. Enter. So when you are deleting this one, you will be getting 7 points inside. 1, 2, 3, 4, 5, 6, 7. Okay. Let me make some reference lines there by clicking this point. Okay. Fine. Now you can copy this. Copy. 2, 3. Okay. Okay. And now this side, 20 meter you have to divide. As you know, the maximum protection area will be 12 meters square, right? Protection area is 12.1 meters square. Now the distance between the sprinkler, we have taken how much? Distance between the sprinkler means alternately, when we are placing it, alternatively only we will be placing it. The distance between the sprinkler, first suppose, for example, the first sprinkler, if you are placing here, the next one you will be placing here only. 1, 2, 3, 4. Like that only we will place it. So the distance between the sprinkler you can find from here. Okay, this distance you can consider S. So then the next sprinkler, this distance you can consider L. Okay, what is S we can? So you can find from there when we are placing 4 number of sprinkler within 4 meter we are getting. So the coverage area is 12.1 meter square. Okay, means S into L is equal to 12.1 meter square. S we are already having like a 4 meter now, correct? 4 meter. So 4 meter into L is equal to 12.1 meter square. The other distance you will get L is equal to how much? 12.1 divided by 4. So 12.1 divided by 4. 12.1 divided by 4. 3 meter here you have to place. 3 meter. Okay, 3 meter. Now I'm just making a line there. 20 meter. Within this 20 meter, each 3 meter distance I have to place sprinkler. How many sprinkler I can place? 20 divided by 3. You are getting 6.6. You should not round that into 6 meter. Then the distance between the sprinkler will be increasing. So the coverage area we will lose. So 6.6 number of sprinkler, we have to round that into 7 sprinkler. So in this line, we have to place L direction this side. We should place how many number of sprinkler? 7 sprinkler. 7 sprinkler means this line you have to divide it with the 14. Okay. div, select the line, 14, enter. So you'll be getting the division points there. So this is the first point. And now alternatively, you can place it here, 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 here. Okay, this one has wrong. Select it, copy that one. This here, then we can place here, then one number here, another one. Okay. Now what we have to do, we have to place the sprinkler accordingly. I'll be selecting a sprinkler from a reference. Now we can place it. The first sprinkler you have to place there. The next one here, third one here, the fourth one there. Okay. All the other sprinkler you can place accordingly. Here, there, here, 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 and so I have placed all the sprinkler. Now distance between the sprinkler, if it is yes, the distance between the sprinkler is yes, and this direction is L. Then maximum distance from the wall is S by 2. In this direction also, this will be L by 2. But minimum distance, this is 4 inches only, 100 mm. So between 100 mm to 2 meter, in this direction, that is 2 meter only. So anything is permissible. But when you are dividing like this, like that only it will come. You don't want to worry. So since the distance between the two sprinkler is 4 meter, maximum distance from the wall will be getting 2 meter. So that will come accordingly. So the distance between this 2 sprinkler, now it has changed a little bit when we are adjusting that into 7 number of sprinkler, 2.857. So distance from the wall will be 2.857 divided by 2. Like that only it will come 1428. Okay. Fine. Fine. Keep this space there. So let me delete. I don't want this reference line anymore. So I'm just deleting it. Select it, right click, select similar, delete it. Okay. Now, type of sprinkler routing, we are having tree routing, we are having gridded routing, pipe sizing for gridded routing. Then we are having looped one, so that in a separate video I'll be uploading for that. For time being, this one I'll be tree routing I'll be doing for this one. So let me take a pipe and I'll be making a route here from here to here. Okay, make it like bi-layer. And after that, somewhere from here, I'll be making a line like this that is going outside. Okay. That is for the layer only. Fine. Now the pipe sizes we should mark. Before that, pipe sizes we can do by two methods. Either by a pipe schedule method or using hydraulic calculation. Adjustment, or you can do one thing, pipe sizing we can do by the help of pipe schedule method, but hydraulic calculation we can use to calculate the water demand. Okay, I will explain that. This is my route, tree route only this one. And this is gridded route. Pipe sizing of tree routing, gridded routing, looped routing is different only, 5 dimensions. With respect to the coverage area only, we have to do the gridded routing and all. Anyhow, I will upload a separate video for that. Fine. Now the pipe sizing has to be done. You can go to page number 232 in here, ordinary hazard pipe schedule. Light hazard, you can use this one. Page number 230 in, this is NFPA 2010 only I'm using. NFPA 13. Whatever it may pipe schedule, whatever the version it may, pipe schedule method remains same only. Okay, 1-inch pipe you can connect 2 number of sprinkler, 1 into 1/4, 3 number of sprinkler, whether that is steel or copper. The pipe material that we are using is schedule 40 steel only. Anyhow, this is light hazard. We are dealing with ordinary hazard. So ordinary hazard, schedule 40 steel pipe, 1-inch pipe you can connect maximum 2 number of sprinkler, 1 into 1/4 inch that is 3 number of sprinkler, 1.5 inch that is 5 sprinkler. Accordingly, you can place it. Anyhow, let me select it. And this will be 2 number of sprinkler, because in this line I am having only 1 sprinkler. 1 sprinkler, the dimension will be 1 inches, 25 mm. See, 1 inch is 25, 1 into 1/4 is 32, 1.5 inch is 40, 2 inch is 50, 2.5 inch is 65, 3 inch is 80, like that it will go. Okay. So there we are having 25. So in ordinary hazard, 25 mm, 1-inch pipe we can connect 2 number of sprinklers. So this is 25. So here also we are having 25. But here the number of sprinkler is increasing. Here also. Correct. How this will come? So anyhow, for this building, we will be having a vertical pipe. That vertical pipe is called riser. From the riser, we will be having this pipe. From the riser, for each floor, we will be taking a branch. This branch is called a cross main. That is called cross main. When we are taking the cross main to each branch, sometimes we might be required 1 cross main, sometimes we might be required more. With respect to the zone only we can do. Here to address the flow rate, we will be having an ZCV, zonal control valve assembly. And now the cross main will be taking a vertical pipe, 100 mm nipple will be taking there. Then from there we will be taking branch. This is called the branch lines. So actually from this point, we are having a vertical line to avoid the contamination should enter into the nozzles when the pump is working. So that's why if you are taking a vertical one, and that is also condition only as per NFPA 13, always it doesn't matter. But most of the cases, no, otherwise I have to explain the NFPA 13 in detail. But okay, for your knowledge, to avoid the contaminations that is going to enter into the sprinkler nozzle, we are providing. So that's why when the system is working, by gravity, the contaminations will be accumulated on the bottom. So up to a certain extent, the dirt particle, corrosion, residues, nothing is going to block the sprinkler orifice. That's why we are providing this one. Okay. Anyhow, the maximum number of sprinkler that we can connect in a branch line is 8 numbers only. Maximum number of sprinkler that we can connect in a branch line, 8. In a cross main, that is 8 plus 8, 16 number. Here 8 number, here 8 number. Total 16 number we can provide. If it is beyond 16 number and the additional cross main we required there. From here we have to take a branch, additional cross main, like that we have to provide it. Okay. Anyhow, in page number 230 of NFPA 13-220, here you can see branch line. Branch line shall not exceed 8 sprinkler on either side of the cross main. But we can go to maximum 10 number. Means the last last one, this branch dimensions we are increasing to next pipe means 1 into 1 by 4. We can accommodate 9 sprinkler. But the last 2 pipe dimensions we are accommodating, then up to 10 sprinkler we can accommodate. Last pipe, instead of 1 inch, if you are making 1 into 1 by 4 inch, then the number of sprinkler in a single branch line, we can, one side we can accommodate 9. If we are increasing that into 2.5 inch, last 2.5 inch and last one into 1 by 4, then we can accommodate maximum 10. But that one, it is there in the detail. In the further classes, I will explain. Okay. So that's why maximum number of sprinkler that we can accommodate in a branch line is 8 number only. 8 number in this side, 8 number here. Anyhow, we are having 3 number here and 4 number there. So we are safe only. Okay. That's why in our case, here we are having a vertical one. This is, you can see this first sprinkler, second sprinkler, third, this is 25, 25. This one has to be increased. Also here we are having another sprinkler. That will be a single sprinkler only. So that's why that is 25 mm. And what about here? This is 25, 3 number of sprinkler. If it is 3 number of sprinkler to 3 number of sprinkler, the diameter should be 1 into 1 by 4, 32 mm. So this will be 32. So I'll be marking that as 32 mm. Okay. And we will be having a vertical pipe there. Correct. A vertical pipe, this one. So that will be, we will be having 4 number of sprinkler. So in this line and that vertical line, we'll be having the same number of sprinkler only. So what about that one? And this will be 4 number of sprinkler. Above 3 up to 5. Above 3 up to 5, the diameter should be 1 into 1 by 4 inch. 1 into 1 by 4 is 40 mm. So this one you can keep 40. Pipe schedule method, you can keep 40. But in hydraulic calculation, we can change that 40 mm. Okay. The same way, I will be placing this to everywhere. Copy. With respect to this point, you can place it there. Because it will be similar only. No? But cross main dimensions has to be adjusted. Okay. Now, in this line, we are having 4 plus 4, 8 number of sprinkler. Here we are having 8 number. So 8 number of sprinkler, above 5 up to 10, that should be 2 inches. So this diameter I need 50 mm. Okay. Then 4 plus 12 sprinkler. Above 10 up to 20, I need 2.5 inch. 2.5 inch is 65 mm. So this will be 65. Then this will be also 65, correct. Up to 12, 10 number, 1 to 50, 65, 65, 65, we can accommodate maximum 20 numbers, correct. 2.5 inch, 20 number of sprinkler. So 1, 2, 3, 4, 5, and this is also 65 only, 5 into 4. So this will also come like 65. Oh, my mouse is, okay. Now we are having like 20 plus 4, 24. About 20 up to 40, we need 3 inch pipe. So this will be 3 inches. 3 inches means 80 mm. Schedule 40, 80 mm. Nominal pipe says 80 mm only we are getting. But at the same time, we will be having a zonal control valve, the ZC. Zonal control will have a butterfly valve, and it will be having a flow switch, a tamper switch, and a drain line. Okay. ZC. So like normally for ZCV assembly will come like this. We'll be having a butterfly wall with a tamper switch, a pressure gauge. It's a flow switch only, and this is a drain line. Okay, in detail, we will explain. Now, this is pipe schedule method only, as per the pipe schedule. But now the next step, I should calculate the water demand, how much quantity of water I required for the sprinkler. Water demand, we can calculate by the help of pipe schedule method. Pipe schedule method with respect to the coverage area. For example, we are having a protection area, sprinkler protection area or coverage area that we can, let me check, that is in page number 228 or 229, not this one. Page number 229. Minimum design area. Here you can see the minimum design area to consider normally for hazard category. For ordinary hazard wet pipe system, 1,500 square feet has to be considered. 1,500 square feet. So based on that, we can find it. For example, we are having a curve called density curve. In page number 121, you can find density curve. In this density curve, we found that the protection area of ordinary hazard from the previous table, that is 1,500 square feet, because fire, it is not going to happen everywhere at the same time. In an isolated area only will happen. So that's why, suppose if we are having a building of 1 lakh square feet, 1 lakh square feet, we don't want to consider for water demand calculation. So how much area has to be considered for protection? And that area only we will be considering 1,500 square feet. From there only it will be spreading to some other spaces. That's why for in this table, from this area density curve table, density area curve table, we can find the area, ordinary hazard. X-axis we are having density in GPM per square feet. Each square feet of floor area, how much GPM of water is required. Here you can see the protection area of sprinkler, area of operation of sprinkler in square feet. For light hazard and ordinary hazard, normally we will be considering 1,500 square feet only. For 1,500 square feet, ordinary hazard group 1, our demand will be 0.15. So the floor area will be 1,500 square feet. 1,500 square feet. So 1,500 into 0.15. When you are doing this calculation, you can find the sprinkler water demand. 1,500 into 0.15. You need 225 GPM. That is our sprinkler demand, 225 GPM. Plus hose stream allowance you have to consider. For combined system, just below you can see hose stream allowances. For ordinary hazard category, total combined inside and outside hoses. These landing valve only NFPA 14 included. Total combined. In only inside hoses, you should consider ordinary hazard. If you are not having any landing wall or hose station, the value will be 0. One hose, you have to consider 50 GPM. If you are having multiple hoses, 100 GPM. But outside hoses, if you are not having, you have to consider just 100. For ordinary hazard, 100 only. External hydrant also, when you are considering, you have to consider 250 for ordinary, 100 for light hazard. 90% of buildings that we are dealing in the MEP industry is light hazard only, but parking area, kitchen area and all will come different occupancy hazard. Okay, anyhow, suppose if this is an ordinary hazard, if you are having external hydrant also, then you should add, along with this 225, you should add a 250 GPM. If you're not having external hydrant, then you have to add 100 GPM. So accordingly, 250 plus 225, how much it is? 475, correct, 475 GPM. This is your sprinkler water demand. Easy calculation, correct. It's easy calculation only. But in pipe schedule method, actually in each sprinkler, the pressure drop will come. Each sprinkler, the pressure drop will come. It is clear that, no, because in this loop, the pump has to overcome. When the water is flowing within the pipe, the pump has to overcome the material losses, the fittings losses, the residual pressure, static head, everything we have to consider, right? That's why in pipe schedule method, water demand, we will be simply calculating by the help of, because every building, it is not, certain area restrictions are also there for light hazard. Every building, it is not practically possible for light, this one, which one, pipe schedule method. We should go for hydraulic calculation. So that's why when we are considering all these pressure losses into consideration, the flow rate might be slightly increasing. So that's why in hydraulic calculation method, we will be considering the pressure drop that is going to happen in each sprinkler node and other loops. Then the flow rate we will be calculating accordingly. Pressure also. How much pressure we required, that also we will be calculating accordingly. So that's why the next step, I'm just going to calculate the hydraulic calculation. So to perform the hydraulic calculation of this line, and after the hydraulic calculation, I will be arriving the pressure requirement of this floor and how much PSI required. And also I'll be calculating the sprinkler water demand. Then combined also we can calculate. Now we are doing the sprinkler system. So let me, to do the perfect isometric, this one, no, which one, the hydraulic calculation, I need the isometric layout. So that's why I'll be preparing my isometric layout. Okay. So I'll be changing the snap into isometric snap. And let me, isometric layout, it is not mandatory to provide the dimensions perfectly. But if you are providing the dimension, then it will be easy to do it. Okay. Anyhow, let me take the dimensions for time being. The distance between the sprinkler is how much? 4 meters this side. And this will be how much? 2.857. And this distance is 1204. And this distance is 279. Let me create it. Okay. So the first one I am making from here, this sprinkler is called a hydraulically most demand sprinkler. When you are doing the hydraulic calculation, for example, if you are having a multi-story building and this is your riser, every floor we might be having a cross main and a lot of branch lines will be connecting there. And your pump might have located on the bottom level, ground level or somewhere. And from the pump suction to the delivery, the last one, that is called the hydraulically most remotest one. Only that sprinkler you have to consider as the critical path. The critical path means the path in which a maximum pressure drop can come. Based on that only we will be doing it. Okay. Anyhow, in our case, this will be the longest one. And this one is called HMD, hydraulically most demanding sprinkler. Okay, so from that sprinkler to the next sprinkler 4 meter, let me take a polyline or line. I'll be making my hydraulic, this one, take it there. And the distance is 4 meter. Let me provide 4 meter. And the first sprinkler has to be provided there. So let me select a sprinkler there. Copy. So that is my sprinkler, that is pendant only I'm providing, pendant. That is my sprinkler. Okay, fine. Now after 4 meter, again we need the next one. So this is my next sprinkler. Now from this sprinkler to here, this is also 4 meter only. Okay. So from this point, you should mark a 4 meter. There also we should connect the sprinkler. Copy. So when you are making the isometric layout, the calculation will be easy. And this distance is the next one, 1204. 1204. Okay, that is 1204. From there, it has to come down slightly. So this vertical height here, I'll be considering 100 mm. That is 100 mm only. And also from this point, we are having a next sprinkler 2795. 2795. Let me create it. Here I'm having a next sprinkler 2795. And this one I can place there. And from this point, I need this cross main 40 mm 2857. So there I need slide 2857. 2857. Okay. And from there, I have to place this loop again. This typical, no? I need that there as well. Copy, select it, and place it there. Okay. Now every 2857 we require that, so let me copy that. Okay. So copy, CO enter, or you can click here. How many? Like 1, 2, 3, 4, 5, 6, 7. This is 3, 4, 5, 6, 7. Okay. Now from this point, it has to come until here. What distance we are having there? From there here to the wall, 1428 outer wall. From this line to here, that is 1678. 1678. So from this line, I need 1678. Okay. From there, I'll be taking a vertical. Let's say I'm having a vertical height of 12 meter. A vertical height of 12 meter or 10 meter, let's say. I'm assuming that. Or this one we have to take as per the layout only. So for this class, I'll be taking this is 10 meter. 10 meter. And then from here, it has to connect to the pump. Okay, it has to connect to the pump. So let me select it. This distance I'll be taking nearly 15 meter. And in between this line, I'll be having standard pump connection, pump suction line. If it is a negative suction, a footwall will come. But normally fire pump will be positive suction only. So in the suction side, we will be having a vortex inhibitor. A vortex plate will come. In the suction side, we will be having an isolation valve. In the suction side, normally the standard fire protection for all the pump, almost all the pump, the fittings are common only. Suction side, we'll be having a vortex plate. Then we'll be having an IV. Suction side, we'll be having a strainer. Okay. Then we'll be having a flexible connector, and we'll be having an eccentric reducer. Delivery, we will be having a concentric reducer. Depends on the pipe size and the pump connection. Sometimes if the pipe diameter and the pump inlet is and outlet is same, you don't want any reducer piece there. Okay, anyhow, to decrease the velocity and to prevent the vortex effect in the suction line, normally in the suction side, we will be connecting eccentric reducers only. Okay, anyhow, just for your knowledge. Then after that, in the delivery, again, we will be having a flexible pipe connector. Then there we will be having an NRV. Then there we will be having an isolation valve, IV. Okay, IV is there and NRV is there. Okay, so anyhow, minimum 3 I'll be considering now. At least 3 fittings I should consider. Let me connect it. Okay, anyhow, let me select it. I will be having like okay, so that is my isolation one. Then then I need a check valve, another IV. At least these 3 you should connect. Okay, and this has to be connected there. At least these 3. So select it, copy, and I'll be placing it there. Minimum this fittings. Okay. So these 2, then deleting it. Clear? Okay. And now I should mark the pipe dimension. Let me select it. As per the drawing, let me select this is 25 mm and 25 mm. This is 32, 25. The pipe, it is going down. This one and this vertical pipe, that is, this is 25, 25, and this will be 32, and there it is 25, and this will be 40. Up to 5 sprinkler, that is 40 only. And the same you can mark it. Okay. So copy with respect to here, I'll be marking it there. Okay. See this cross main, in my case, no, this cross main, here it is 40, 40, then after that I have to increase that into 50, 65, 65. So different dimension if I am having in the cross main, my hydraulic calculation will be difficult. So to make my calculation easy, you can keep it like this, no problem. But I'll be making this as 3 inches because it is not pipe schedule, combination, no, pipe schedule I have used for branch sizing, but this cross main to make my work easy, so I'll be maintaining a constant diameter, 80 mm. That will be easy, means throughout this one. After this, if it's a combined pipe, you can decrease it, because if it is a combined system, whatever the system, it may at least 100 mm we have to provide. Depends, no? NFPA 14 we have discussed already. So that is 80, and even this is also 80, even this is 80, 3 inches, 80 mm. Okay. So this is my layout. Now the dimension, we have already taken from here to here. The distance, no? From here to here, that is, we know that is 4 meter, aligned one, aligned dimension. From here to here, that is 4 meter only. Okay. Distance between, this is S and this is L. 2.8, not 2.83, it is exactly 2.857. Okay, fine. Now, height, you know, that is 10 meter only. The height is 10 meter. From here to here, that is 10 meter. Okay. Now what I have to do, I have to do some calculations and all. Means, as I told, if you're having this many number of sprinkler within your space, to do the hydraulic calculation, you don't want to consider your entire space. Protection area means within the hydraulically demanding protection area you have to select, only that area you have to consider. The protection area for light hazard category, whether that is from our NFPA 13 or from our class note. See, for light hazard category or ordinary hazard category. For ordinary hazard category, the maximum sprinkler protection area is 130. This is for single protection, but coverage overall protection area is 1500. No, 1500 has to be considered. Correct. In page number 229. Correct. Protection area is 1500. Okay, so only that 1500 you have to select. Based on that, you have to design it. Okay. Anyhow, I'm just proceeding my hydraulic calculation. Before